We're going to fill in the rest of that table. There are 4 blanks, and we're going to fill them in today. And you say, Jason, how are you starting with an example if we haven't talked about the derivatives of the other trig functions? Watch this. Find the derivative of tangent of x. You have to do it. I'm not giving you this one. You have to do it. And you might say, Jason, proofs of these theorems are so hard. How are we going to do this? The answer is, it's going to be way easier than the sine proof. Okay? Why is that? Let's look at it. The derivative of tangent. What is tangent? There's a couple of ways of thinking about tangent, but one of the ways is thinking of tangent as sine of x over cosine of x. Oh, well, now this is too easy. This is too easy. Why is this so easy? Because to find the derivative of tangent of x, to fill in that next thing on our table, we already did all the hard work. We already found the derivative of sine. We already found the derivative of cosine. To find the derivative of two things quotiented together, that's not a real word, divided together, the quotient of two things, use the quotient rule. All right, so let's call this f. Let's call this g. F of x is sine of x. F prime of x is cosine of x. No fancy crazy proofs to do here. G prime, going to be negative sine of x. You can actually do all of these new ones, right? Tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. So you can just do all of these on your own. All right, let's use the quotient rule. That's low d high minus high d low. Square the bottom and away we go. And don't screw up your negative sign, Jason. F prime is cosine times g, which is cosine, minus f, which is sine, times g prime, which is negative sine. I'm going to just flip this to a positive. Ooh, this is nice, Jason. And now g squared is cosine squared. Now there's a couple of ways of proceeding from here. One of them is to look at our numerator. That's just cosine squared of x plus sine squared of x. And remember, sine squared of x plus cosine squared of x, that's always equal to 1. That's our Pythagorean identity. This is just that. Just 1. We have 1 over cosine squared. What's 1 over cosine squared? Secant squared. Derivative of tangent is secant squared. So let's fill in our table. All the way back here. Derivative of tangent is secant squared of x. Similarly, the derivative of cotangent is negative cosecant squared of x. So there's a lot of similarities. There's a lot of patterns here in trig. Okay? Derivative of cosine is negative sine. Derivative of cotangent is negative cosecant. In fact, it's going to turn out that the derivative of anything that has a co in it would be negative. Derivative of cosecant is going to be negative. It's negative cosecant x, cotangent x. Pretty sure. I actually haven't done these for a really long time. I'm pretty sure this is right, though. All right. So again, cosecant and secant have very similar derivatives. Just the cos have cos. And cos are always going to have a negative derivative, right? Secant tangent, cosecant cotangent, almost the same thing. Derivative of sine and cosine, again, sine and cosine. And the negative goes on the one that was taking the derivative of a co-function. Tangent and cotangent, very similar derivatives. And there's just a negative on the cotangent derivative. All right, so a lot of this stuff. All right, this... I should have written this down. It's been so long since I've done derivatives of trig. Pretty sure it's right, though. We'll check our answer to the first problem here, and then that'll tell us whether we're wrong. Example 4, find an equation of the line tangent. Oh, we love tangent lines. To f of x equals cotangent of x. Let's change it. Cosecant of x at x equals pi over 4. All right, so tangent lines, right? We're just going to use point slope form. And we just need to figure out all of these things. So we know our x, right? It's going to be y minus, we don't have a y value yet. We don't have a slope yet. We know the x coordinate is pi over 4. We just have to find that other stuff. So why not? That's just going to be the function evaluated at pi over 4. Cosecant is 1 over sine. So it's the reciprocal of sine of pi over 4, which is 1 over root 2. The reciprocal of 1 over root 2. You could use your reference triangles to need to refresh your trig. The 45-90 triangle, that's going to be the useful one here. As these ratios. That does not look like a right triangle, Jason. Nice try. So it's 1 over root 2. All right, so fill in the blank. Y minus the square root of 2. Last but not least, we just need the slope. Slope function is the derivative function. Derivative of cosecant is negative cosecant of x times cotangent of x, purportedly. Ooh, I haven't used that word in a while. Purportedly. I like that one. I think that's how you say it. So what is the slope? Again, this tells us the slope of the slope of f at any point. But we only care in this problem, we only care about what is the slope at this point. That's going to be negative. So again, cosecant is 1 over sine. And cotangent is 1 over tangent. You don't have to do it this way, but I like writing it as 1 over because I don't have a lot of experience with cosecant, secant, and cotangent. I don't have a lot of experience with the reciprocal functions, but I have SOHCAHTOA pretty good, but I don't have the SOHCAHTOA for the reciprocal functions. I don't even remember what it is. I've done it before. You know, you could go like, it's so because sine is opposite over hypotenuse. You can do the same thing with like cosecant. Cosecant would be hypotenuse over opposite, and then secant would be hypotenuse over adjacent, and then cotangent would be adjacent over opposite. So it'd be cho sha sao or something. Sounds like I'm trying to speak bad Chinese. All right. But yeah, nobody really remembers that. So again, sine, just like before, sine is 1 over root 2. Tangent of pi over 4 is just 1. So actually, it just simplifies the negative root 2. Right? The reciprocal of root 2 is just root 2. And then the reciprocal of 1 is just 1. Multiply it out. So if I didn't make any more mistakes, this should be the equation of our tangent line. And every time, literally every time you're doing a tangent line, just take 15 seconds and graph it. It's really, really obvious to see if you messed up in most situations. All right, we're looking at the cosecant, tangent line to cosecant at pi over 4. Question is it y minus the square root of 2 equals negative square root of 2 times x minus pi over 4? Oh, whew. I was getting a little nervous on some of these problems. I had a bad track record the last couple of weeks. But that's a tangent line. Right? Look at it. It just skips right off of it. the tangent line. Woo. There we go. It's not a tangent line here though, but we're looking at pi over 4. Pi over 4, pi is about 3. So pi over 4 is about 0.75. All right, cool. That's all we're doing in this video. So you're done with math. No, you're probably not done with math. You probably got a lot of math left, but don't lose hope. There's only one more video of new material and then some problem solving, optional problem solving. You're doing great. Good job. Bye-bye.